Ladies and gentlemen, I have great news. The puzzle has yet to be solved. No one has yet figured it out correctly. We have several people who have incorrectly solved it by forcing the wood through the ring. The object is to get the ring out without, uh, I guess, cheating by putting the wood through the ring. The prize is still standing for you, and hopefully we can get someone who can figure it out before or after school. Today we're talking about radical equations. They're radical because they're awesome, and they are also very, very simple to solve. These are warm-up problems that we worked on at the beginning of class for today, and we're going to get going with our simple talk about radical equations. Here's our new steps. We're going to solve radical equations. We're going to also learn about something called extraneous solutions. We're going to use radical equations. Those are equations that have variables in the radicand. The radicand is, again, the stuff that's inside the square root sign. Extraneous solutions are solutions that aren't really a solution to the original equation. So we'll have to make sure that we check our answers very, very carefully. All right, let's get rocking. This is the main idea here. We're talking about how to solve, I guess, radical equations. You can to get rid of a square root, you would square both sides of an equation. Remember, whatever you do to the left side, you got to do to the right side because it's math, and math is always fair, kind of. So here's our first problem. An object is dropped from an unknown height, and it reaches the ground in 5 seconds. Use the equation t is equal to the square root of h divided by 4, where t is the time in seconds and h is the height in feet, to find the height from which the object was dropped. So our job is just going to be quite simple, to plug in, let me find my calculator, to plug into the equation. So they have given us so far the t for time. So in for t we put a 5 seconds, and in for h we're going to keep it an h because that's what the question is asking us to figure out. That's an h, and we divide by 4. So for us, let's make sure it looks more like an h. There we go. For us to solve this, we need to get the square root of h by itself. So we go times 4 to both sides. So that gets rid of those 4's. So we now have 20 is equal to the square root of h. Now to get h by itself, we need to get rid of the square root. So we're going to take and square both sides so that the square root will go away. 20 squared is 400, so 400 is equal to h, because the square root of h squared is just an h. So that means that the height of this object would be at 400 feet. Now we would take and we plug that back into our calculators. So I'm going to plug in 400 for h. So I'm going to do the square root of 400. I'm going to divide it by 4, and it equals 5. So when it equals 5, I know I've done things correctly, and I've double checked like I'm supposed to. Perfect. Moving on, same kind of a process. See if you can solve this one. Instead of having our t be 5, our t is going to be 7. So in for t we have 7. So equals to the square root of h divided by 4 times 4 times 4. And we get 28 is equal to the square root of h. We're going to square both sides to get the h by itself. So I don't know what 28 squared is off the top of my head, so I'm plugging in the calculator, and I get 784. So h is equal to 784 feet. Moving on. Same kind of a process, but on this kind of problem, we need to get the radical by itself. So I'm trying to get this whole thing by itself first. So I'm going to go minus 8. So I have the square root of x minus 3 is equal to 7. Now I'm going to square both sides to get rid of the square root. So I have x minus 3 is equal to a 49, because 7 squared is 49. Now to get x by itself, simple steps here that you guys all should know how to do. So x is equal to 52. Now because x equals 52, we're going to plug it back in and double check. So 52 minus 3, square root of 7, 7 plus 8 is 15. Perfect, the solution works. Now, same process, you can go ahead, this is your multiple choice question. Good luck. Here is where things get just a touch more tricky. So in order to get the y's by themselves, we have to again do the squaring on both sides. So when we square both sides, we get 2 minus y is equal to y squared. Now we're going to make this just like we did in chapter 7. We're going to get the y squared, and we're going to have this equal to 0. So we're going to move this stuff over here to the other side because we like our y squareds to be positive. So we're going to go minus 2 and plus y to both sides. Minus 2 and plus y. So that cancels and that cancels. So I have 0 is equal to a y squared plus a y minus 2. Now we should be noticing from here that this is going to be able to be factored. So I'm going to be able to go y, let's see, I have a y here and a y here. What multiplies to make a negative 2 but adds to make a 1. So I'm going to have a 1 and a 2 here. And I need my positive to be with the 2 so that when I subtract this 1 it stays positive. So now because this stuff was equal to 0, I'm going to then make each equation equal to 0 to check. So when I do that, here's the work. We check our answers, plugging it all back into the original equation, and when we plug it in, you can see that 2 does not equal a negative 2, so that solution, a negative 2, does not work. So only one of our solutions, our extraneous solution, would be where y is equal to negative 2. So 1 is the only solution. So this is the same process that you will use for this problem. This is your open response question. Make sure that you are double checking to find your extraneous solutions. Good luck. Have a great day.